Okay, let's look at number 4. Number 4 is an actual piecewise function because it has more than one part. These were kind of warm-up exercises to get you to understand how to graph just part of a line. Now we're going to take the whole thing together. I'm going to have actually 2 parts on one graph. So the way that they write this, each line is its own graph. Okay, so that x minus 2 and then you comma x is less than negative 1, that's one graph that you're going to put. And then x plus 3, comma, x is greater than or equal to negative 1 is your other part. So I'm just going to look at that top part first. So what that is actually saying is y equals x minus 2 is your equation, and they want you to show only the part of the graph where x is less than negative 1. So if I wrote that in interval notation, I would have from negative infinity, and then it's going to stop at negative 1 and not include that value, because you want everything that's less than negative 1. So let's graph just that part, and then we'll deal with the other part of the equation. So my y-intercept is at negative 2. My slope is a positive 1, so I'm going to count up and over. And let's graph that line. Okay, so the part that I want is from negative infinity to negative 1. So I'm going to find where x is negative 1. Go down to the graph. I want the half of it that's going to negative infinity, so that's the left side. So I want to erase everything on the right side. Also, at that part of the graph where x equals negative 1, I need an open circle because that value is not included. Okay, so that is that first part of the piecewise function. So let's graph the second part now. The x plus 3 is your equation. So y equals x plus 3 is what I'm going to graph. That's the line. The comma separates the equation from the domain restriction. So the second part, x is greater than or equal to negative 1, that's telling you what part of the graph they want you to show. So writing that as an interval, it's going to include the negative 1 and then get bigger than negative 1. It's going to go on to positive infinity. So I'm going to have a bracket, starts at negative 1 and then goes on to positive infinity, close with a parenthesis. Okay, so this line, x plus 3, have a y-intercept at 3, slope of positive 1. So if I graph that line, that's what that would look like. Those two lines are going to be parallel to each other. I only want the line starting at negative 1 for x and going on to positive infinity. So here's my value where x is negative 1. Here's my graph. I'm going to leave that one colored in because that value is included. It's going on to positive infinity, so everything on the left side of it is going to get erased. Okay, any questions? Okay, so let's look at the domain and range. They're going to ask you to write domain and range. Domain is left and right. Is there anything that is not being covered on the domain? You have an open circle here at negative 1, but right above it is a closed circle. So even that's being covered on my x values. So this is going on to negative infinity. This is going on to positive infinity. I am using every x value. There's nothing that's not being used. So my domain would be all real numbers. Now for the range, That's where it's a little tricky, because you're looking at your y values for the range. And you can see there's a big gap right here in your y values. So there is going to be something different that you have to write down. Okay, so for this top part, what y value does the graph start at?
3.
Close. It's 2. Here's your origin right here, and it's up 2, right? That's where your graph is starting. So that means when you write your range, you're going to have all values of y, so that y is greater than or equal to 2. And it's included because that is a closed circle, so it's greater than or equal to. Or, how would you write this other one? Where does that value start? -3. Or y has to be less than -3. It's not equal to the second one because that's an open circle. And there's your range. Any questions? Okay, let's look at number 6. You have 2 equations for number 6. We're not going to pay any attention to this absolute value one right now. Let's just graph the step function. The piecewise function. Okay, so break it up into 3. Graph each part, and then let's see what everybody gets. I'll do it up here. So we're going to start with the first one. I'll let you guys go ahead and start, and I'll give you a second. Okay, let's go over it together. I wrote it separately. So this first equation is just y equals x. Okay, so it has an intercept at 0 and a slope of 1. So it's going to be really the identity line, right? Just simple line. But I only want the part from 0 to positive infinity. So this is where x is 0. I want the right side because I want it going to positive infinity. So that means the left side I am going to erase. And then we're going to have an open circle for x is 0 because that point is not included. Okay, so the next part, I'm going to draw the line y equals 0. It's that horizontal line. It's actually the x-axis. But the only part of the line that I want to show is where x is 0. So I just have this one point on the line that I'm going to color in. That's the only part that they want you to show. So everything else on either side, I'm going to get rid of. Okay, so I got that one. Now the last one is y equals -x. So I'm starting at the origin again. Y-intercept is 0. But my slope this time is negative, so I'm going to go up 1 and then to the left 1. So it'll make it a negative slope. I'm going to go on the other side too a little bit and draw my line. Okay, but the only part they want me to show is from negative infinity to 0. So negative infinity is on the left side of the graph. They want you to stop at 0. So everything below that, or on the right side of that point for x, I need to erase. And I'm drawing an arrow. There we go. Okay, and there's my graph. Now the reason they had this absolute value graph right next to it is because these are actually the same graph, written two different ways. Okay, so if I wrote the domain and the range, let's do that real quick. Your domain is your x values. Okay, is there anything that x cannot be on this graph? No. X can be any number, any value, so that's all real numbers. But the range does have a restriction, right? Your y values. Where do your y values stop?
At 0.
At 0. So you can only have values for your range that are positive, that are greater than or equal to 0. So you've got to use your set builder notation, all values of y, so that y is greater than or equal to 0. And then close it with your bracket. Any questions? Yes.
On that one, why can't you just put a capital W to symbol all whole numbers? Oh, it's not. Never mind, I answered my own question.
Okay. Anything else? Okay, let's look at number 7. Number 7 is an absolute value equation. So what kind of shape is it going to be if it's absolute value? A V. So you know that if you start graphing and you don't have a V shape, that something's wrong. Okay, you know you need to look at it some more. So for these graphs, let's make a table of values. And I'm going to show you a trick to help you graph these. The V doesn't always start at 0, 0 like this one did. That's just the parent graph, so it's the simplest form. This is going to be a little bit different because you have some things being added to it, being multiplied to it. Okay, so what you want to do, what you want to think about is, what value can I put inside this absolute value to make it 0 inside? That's the first thing you want to do, is make that a 0 right there. So what can I put in for x to make that 0? 0. 2 times 0 is 0. So when x is 0, y is going to be what? Negative 4. So let's plot that point first. And that is actually where your vertex is going to be. That's the starting place for the graph. Okay, so I'm going to pick a number on either side of that point, the same distance away. So for example, if I chose negative 2 on the left side, that's 2 units away from that 0, negative 4. So I want to choose a number on the right side that's 2 units away. And in this case, it would just be positive 2. Okay, so let's substitute negative 2 in for the x. 2 times negative 2 is negative 4. Absolute value of negative 4 is 4. Right? So what is y going to be? 0. What about when x is a positive 2? 0 again. Okay, so if I graph those, there I get my shape. And there's my graph. Okay, so let's do the domain and range. The domain, any restrictions on the x? No. That's right, there's not any. So it's going to be all real numbers. What about the range? Looking up and down. Is there anything that y can't be?
Yes.
What?
It can't be anything below -4.
Okay, so it has to be greater than or equal to -4. So you're going to use your step builder notation, all values of y, so that y is greater than or equal to -4. Okay, any questions? All right, we got one more. This last one is a step function. So you know that when you graph this, you should have a graph that has some steps in it. Okay, if you're not getting steps, then you know that you're doing something wrong. Okay, so let's do a table of values again. Now the thing about a step function is whenever you take the number out of your step, it has to be a whole number. So if you have any decimals or fractions inside the step, you have to just truncate that number. Just get rid of all your decimals. Don't round it at all. Just get rid of the decimal part, keep the whole number. So let's put some numbers in for x here. Now for these, whenever I'm putting values in for the x, I try to make this inside the step a positive number. Because people get confused whenever you have negative values inside the step. So since it's a +3, I could start with 0 for my x. And when x is 0, y is 3. Okay, that one is just like normal. Now if I put a decimal in for x, like 0.2, 0.2 plus 3, that's going to be 3.2. When you take that number out of the step function, you have to get rid of the decimals. Just keep the whole number, so it's still going to be 3. Even if x was like 0.7, plug 0.7 in, 3.7. When you take that out of the step function, you have to get rid of the decimals, so it's still a 3. You don't round it. You just get rid of the decimal part. So the y value is not going to change until you put another whole number in for x. So if I put 1 in for x, now I'm going to finally get 4 for the y. So your y value stays the same for a whole unit of x. Okay, so if I put in like 1.3 for my x, I'd have 4.3 inside. And when you take that number out to get your y value, it's going to be 4. So when is it going to change to be 5 for y?
2.
When x is 2. Okay, so let's graph some of this. Now on the bottom part, I'm going to skip one. I want to make this a little more spread out on my x's. So I'm going to put 1 here, and 2 here, and 3 here. And that's -1, -2. I'm going to keep the y values the same. It's going to be 1, 2, 3, 4. But my x's, I'm going to spread them out some. So this first point, 0, 3, is a closed-in circle. That's a definite point. It's on your xy table. So I have a colored-in circle there. And y is going to stay at that level. It's going to stay 3 until x is almost 1. So I have an open circle when x is 1 and y is 3. The next definite point is when x is 1 and y is 4. So now it jumps up to the next unit and it's colored in. And y is going to stay 4 until x is almost 2. Then when x is 2, y jumps up to 5. So I have this pattern going. You only have to graph a couple of steps, and you can see what the pattern is. And then you can start to just fill in, back and forth. You can go down with it as well. Okay, and we have our graph. Okay, so let's look at the domain and the range. Your domain, your x values, is there anything that x can't be? Look at all those x values. Can I substitute any number I want in for the x?
Yes.
Yeah, even these, You have open circle, but above it's closed. So everything is covered. So that's going to be all real numbers. But your range is different. You do have gaps in your range. What can Y not be?
A decimal.
Right. You can't have any decimals for your Y. So what do you call that? If you can have positive or negative whole numbers, what is that?
Integers.
Integer. So but range is all integers. Any questions?